Hello interwebs, welcome to Let's Fix Computers. I've got a Minis Forum Desk Mini PC here, which came in. I think this one is no power. I'm going to double check my notes while I'm talking, and well, unboxing it rather. Where is it? Yeah, that's right. This is in for no power. So we're going to have a look at this guy and see if we can figure out why it doesn't, well, power on, basically. So, and there are a few caveats with this that we need to be wary of. There's the power supply. So this thing has a Type C. Yeah, that looks bad, but it might be okay. 65 watts. Yeah, that's doable. Yeah. All right. So this has a Type C power adapter, but this is not, the customer tells me that this is not a power delivery adapter. And that kind of tallies with what we're seeing here. It's 19 volts, 3.42 amps output. Doesn't list any other outputs. If you look at the label of a proper USB power delivery adapter, there'll be a whole list of outputs of all of the possible output combinations it can do. So we've got to be careful with this because apparently this thing will just not communicate with a real power delivery adapter, which I'll put to the test just for posterity. And likewise, despite being USB-C, you don't want to plug this thing into your phone because this thing will blow stuff up. I'd heard great things about Minis Forum, but I'm kind of disappointed to see this kind of thing. This adapter shouldn't exist. This is bad. You shouldn't make this stuff because people are going to plug this into their phone going, well, it's the universal one. It's the one that works on everything, right? No, this will blow up your phone. Anyway, ran out the way. Let's see if we can get this thing going. Nothing else of interest in the box. So let's put all of this to one side and see if we can learn why this guy doesn't turn on. Roll the intro! So first of all, let's just find out if this power adapter actually works or not. So I'm going to hook this up. We've got a green light on the power adapter. You can just see a frame there. Now somewhere I've got a little breakout board that's a Type C connected to a breakout board that would allow me to probe the pins on it. However, I'm going to try something else instead. I've got with me Paul Daniels's USB Type-C power meter. I'll just show you guys that on camera because I have not shown this thing off yet. People who watch Paul Daniels' stream will be familiar with these guys. It's his USB Type-C power meter. And this thing is really handy because it's got a USB interface to the computer. So not only do I have a live readout on the display, but also I've got this on-screen readout that you guys are seeing as well. So I'm going to unplug my Type-C power adapter from that. And I'll plug in this guy here, and we'll just see what happens. Alright, so that adapter is knocking out 19.5 volts. I'm going to see if it's doing that both directions. Yep, seems to be no issue there. Okay then. Right. I guess I'll plug this in and see what it does. Okay, right. So as soon as we plug that in, the voltage tanks, and you can see we've got pulses of current there. That's a short circuit if ever I saw one. So there's presumably a dead short in this thing somewhere. So let's get to opening this thing up. So you can see we've got the pulses on the graph there. Really clear indicator of the power supply power cycling as it detects a short circuit and cuts in and out. I had a suspicion that's what was going to happen, which is why I hesitated. But I was like, I should take this apart and look first before I just blindly plug it in. However, also, the customer has already tried to plug it in a dozen times. If it was going to blow up any more than that, it would have by now. So, for the sake of the video, let's press on. So I'll take the bottom screws out there and we'll just see what opens up. That looks good. Right, our power input is there. We've got an SSD. We've got some memory modules. We've got our BIOS battery there. This is very similar to another mini PC that I looked at recently, which had a similar kind of case design to it. Just going to pull that back. Nothing exploded underneath there. There's some big looking power planes here, so we might be able to start probing that. But I think what I'll do is I'll take the screws out and see if I can get the motherboard to lift out first. Let's grab this SSD and put it somewhere else. This is basically a laptop on the inside, to all intent and purpose. Let's zoom in a little bit as well. Too far. That'll do. Now the last one of these that I took apart, it was a bit more complicated than just taking out these screws. The top had to come off as well, and it was all pretty horrible, and it was all glued in. I'm hoping this is going to be a bit easier to disassemble. So let's gently have a look. Yeah, that guy's coming up. Get the other side as well. Will that just drop out if I give it a bit of a wiggle? No. The top looks like it wants to come off. If the top will come off, then I will allow it. Whoop, there we go. Try that again. Aha. Oh, that's neat. Okay, I want to disconnect those Wi-Fi antennas in that case. I think I have an email in my inbox from Minis Forum saying, hey, do you want to look at some of our stuff? And I should probably get back to them because I've heard lots of good things about their stuff, and they make some interest. I like these little mini PCs. I think they're very interesting. And, you know, while I've criticized it for having a 19-volt hard-coded Type-C adapter, you know, the rest of the design seems pretty neat. Okay, I need to get this past there. Just a bit of... There we go. I just bent the frame outwards slightly and then it cleared. All right. So that's a neat design. Pretty simple heatsink there, but they put a nice big fan on there. They've put as big a fan as they could reasonably fit onto that, which is good for... which is good for noise. I've just spotted that there. Okay, let's start at the beginning. So in the top left, we've got a Type-C input port, and it looks like we've got some typical DC in circuitry up there. So let's dive under the microscope and take a closer look. So this guy is going to be a fuse, and that does not look like that's blown. So I'm assuming that's our main input fuse. So in resistance mode, I'll put my black probe on this ground pad, this screw hole on the left, and let's just have a quick look at that guy. I'm assuming that's going to be at ground. Oh no, I lie. We have resistance. All right, what about the other side of it? Yeah, same there. Okay. So, so that is going to be our 19 volts in. And just for interest's sake, if I flip the board over again... So we've kind of got a repeat of that on the other side. You can see again we've got this big center one, and all of those black dots are vias, which are going through the board. So it's connecting those big pads on both sides. Lots of stitching there. So we have a very clear ground and 19 volts. So they've just taken the hot pins from the Type-C connector and just plumbed them all into a 19 volt rail. So this is where you would normally just have a DC barrel jack. They just didn't want to put a DC barrel jack on there, presumably because that doesn't look very modern. but whatever. So, okay, let's move a little bit further along then. So we've come out of our Type-C port. We've gone through a fuse into a MOSFET. So what about the other side of this MOSFET? It looks like we come out from there and we're going up. Hold up a sec. What are those? Are those capacitors? Yeah, if we get the light right. Yeah, those are capacitors. They look kind of darkened, actually. Let me get a side-on view there. Those don't look very good at all. I wonder if those are our issue. Let's hold up. Let's carry on taking measurements first. Firstly, is that even shorted? So we come out, we go through this DC in MOSFET, and on the other side we've got these 3 pins and these capacitors. Are we shorted? Yes. So now we're shorted on the output of the DC MOSFET. So my money is on these two guys just immediately. Possibly this guy. It all looks pretty sketchy. Where do we go from here then? Well, again, we've got lots of via stitching going through the board. So let's flip the board over and see where it goes from there. So once we've gone through the board, there is another capacitor on the other side. And then we're coming through here. Now, is that an inductor? Yeah, that's black. So that is an inductor, presumably inrush. And that is then bridging across to there. Is that our only inductor? I'd expect more than one, because this guy's got to carry up to 65 watts. But I don't know. If it's a pretty beefy inductor, then maybe. So then we go... Let's see. Do we go anywhere else? Those look like more capacitors. Yeah. Then 2R2. That looks like a current sense resistor. Difficult to see exactly where the trace is going here. Let's just peel that guy off and move him somewhere else. Let's try getting in closer so I can actually see the traces better. Let's just probe that out. Does this connect to this? We might not be able to tell, because if everything is shorted to ground, then it'll be very difficult to determine. And it's also very hard to hold this steady because I've got the fan on the other side. No, 4 kiloohms. There's stuff between there. Okay. I assume we're still shorted to ground at this inductor, so just put my black probe on. Let's just find a screw hole that I can reach. And check that inductor. Yeah, we're still shorted. I'm really tempted to take a pot shot at those capacitors just because they look really bad. Let's take another look at those. See, the top, they look pretty darkened. And when we get to the side and we go real close up, that one on the left looks like it's fractured to me. I kind of want to trace the circuit out further, but also, like, we've got a smoking gun. I might just go straight in on that. And just try my luck. Sod it, I'm doing it. I'm just going to go straight onto those capacitors and just try my luck. So let's just stick some flux down over there to protect the pads. And we're coming straight in with the hot air. Here we go. Gonna try not to melt this Type-C connector, but nah. Am I going to get the little guy as well for good measure? Yeah, why not? Right, we'll just give that some time to cool down now. Meanwhile, I'm going to have a closer look at this guy under here. These ones on the back of the board look better. So this guy's a little bit discolored, but he doesn't look cracked or anything. And this guy here cannot be our problem because this is before the MOSFET where we're not shorted. Alright, has our temperature come down now? Good enough for measurements. You don't want to measure the board while it's baking hot because you can get misleading measurements. The board flexes, things expand and contract, that kind of thing. Right. Shot in the dark. And... oh, I don't believe it. Look at that. I think I was bang on the money. After a drought of rabbit holes, I'm being rewarded with the easiest jobs in the world. Okay, let's take a closer look at those. Let's take a closer look at those capacitors. Behold, the transistor tester. If you do a search for transistor tester, you'll come up with lots of little widgets similar to this guy that have some kind of screen and some kind of socket for poking through-hole stuff into, and some SMD pads for pressing SMD components against. And what this guy does is you plug it in, you put your component in, you press the button, and it tells you what it is and what it's rated for. Very, very handy tool to have in your kit for just identifying components. They also function as a poor man's LCR meter as well. So if you connect a capacitor up to it, it will tell you the ESR of the capacitor, because some capacitors will fail in a high ESR state where they're not short-circuited and they've got the capacitance, but the ESR has skyrocketed, which means they can no longer respond fast enough to be useful. Common on old capacitors, I think. ESR failure is not something that I see very often in my line of work, but it's a thing. And proper LCR meters are surprisingly expensive. So, let's stick one of these caps on it. Alright, we've got a 10 microfarad capacitor. Seems to work, and 10 microfarads is about what we'd expect. We've got 0. That looks like that one's a wire. Can we retest, please? Yeah, that's showing a resistor. Yeah, that's dead short, that capacitor. So that's our dead guy. And then finally, we've got the little boy. This might be too small to put on this tester. Oops, and it just went flying. Shouldn't have bothered taking that one off. That's fine. That was probably, based on the size of that one, that was probably a 100 nano or something like that. Okay, so the one that was dead, and yeah, the dead one, the one that is dead is the cracked one, just as predicted. So we need two 10 microfarad capacitors and a 10 nano. Now, these are directly on the 19-volt rail, so I've got to make sure that they're actually rated for, they need to be 50 volts. And I don't think I've got any that are rated that high. or 20 volts rather, or 25, something like that. So let me go and have a rummage and just see if I've got something that is rated high enough. All right, I've got a couple of new capacitors ready to go. We've got some 10 microfarad 25 volt capacitors here, and I've got a 100 nanofarad 50 volt capacitor here to replace the one that I lost. Now this guy's kind of oversized, but that's okay. It saves me from having to go and buy a tiny little capacitor, and it'll do the job just fine. How do I know that it's 100 nano, you ask? I'll level with you, it's a guess. However, in cases like this is usually noise filtering capacitance. These are not bulk decoupling capacitors for a main power rail like this. This is to reduce noise on the power rail. It's part of ground loop inductance. It stops the ground plane of the circuit board from functioning as an antenna that transmits noise coming off of the lines as electromagnetic interference. And most of the time you'll see something like 10 or 20 microfarad capacitors doing this job, and there'll usually be another smaller capacitor next to it that is typically an order of magnitude lower. Or 2 orders of magnitude lower in this case. Most of the time when we look at that, we'll see the same. Anyone who watched the MacBook Pro board video that I did very recently, where I replaced a capacitor on the right I/O board, we had a 10 microfarad and a 100 nanofarad. So same deal there, basically. Very, very typical kind of values that you see there. Let's attack this. I am going to plug in my soldering iron, and I'm just going to reflow those pads a little bit because they're a little bit grotty, and because I don't want to put too much power onto because I don't want to put too much heat around that USB port, I'm going to bother to reflow the pads and get some leaded solder on those just so they are nice and clean and reflow nice and quickly. So let's turn this around so I've got nice easy access with the iron. And just blob solder all over that. There we go. Now some flux and wick. There we go. And now I might even be able to just soldering iron hero this, to be honest. Let's put on the 10 microfarad ones first, because the 100 nano I'm going to do some modifications, shall we say. I'm going to scratch the PCB. No, I don't like that. I think we're going to go for the hot air reflow. Nah, I don't quite have the clearance I need to get the soldering iron down there. I could, but not with enough heat, because we're on a ground plane and a power plane. And before anyone goes, get a chisel out, a chisel's not going to fit in there, bro. That'll do. Gonna quit while I'm ahead. And now we'll just do a little bit of scrapey up here. We're just going to elongate this pad a little bit. Flux and solder. There we go. And grab my 100 nanofarad. Needlessly chunky boy coming in. And now we'll just stick some solder on the ends of those. I'll give that some more flux just so we can get some nice ends on those, just for my own peace of mind. There we go. We'll give it a micropole of flux. There we go. There we go. Those are not the straightest capacitors in the world. However, I'm going to quit while I'm ahead, because if I damage that USB Type-C connector, this job is going to get about 100 times harder than it needs to be. Sometimes it's, you know, like I could come in there with a hot air and more flux and just reflow those so they nestle into place. But again, if I damage that Type-C connector, now I've got to find a new Type-C connector for this and then fit that, and just, no. I'm going to quit while I'm ahead. Let's see how this guy looks. Right, so I've got the customer's 19.5 volt Type-C adapter here. It's going through my power meter, so we're coming out on one of my cables. Plug that in. And the computer is powering up. All right. And we should get some signal. Don't know if it's going to... Oh, there we go. Minis for him. Aha. So this should take us to a... Yeah, there you go. It's gone into BIOS because the SSD is unplugged. But that is now a functional mini computer. There we go. That's us done. I'll quickly throw it back together again and we'll wrap up. There we go, and one more time for posterity, HDMI, and I'll plug the customer's adapter just directly into the back now. Plug that in, and we've got a blue light on the front, and we should get a signal out from it in just a moment as well. Minis for them. And that should start booting into Windows because the customer's SSD is in there. Huzzah! That's a cool background. Oh no! And that, everyone, is my heckin' Ava Media capture card going, copy protected content? God, no! Anyway, right, thank you everyone for tuning in. That was a nice little fix, that. I'm happy to get some easy ones because I've had a bit of a drought recently where all of the board repair stuff has been things that are technically doable, but outside of my skill range. So having the easy peasy stuff that is very much in my skill range is a welcome relief. Thank you for watching, everyone, and I'll see you next time. Bye for now.